Hi everyone, in this second part I will show you my process to make the retopology of this character so that it fits our requirements in game. Let's get started. The very first step will be to reduce the poly count of my sculpting. So if I were in Blender, I will use the Decimate modifier, which worked pretty well, and I think you could go like down to 10 or 20% without losing any details. I'm also rotating the axe because I will be using the position of the character to shade it, and I want a top color grading shader later on. So I'm just duplicating my subtool. These are kind of objects in Blender, and then I will run the Decimation Master plugin so that I can decimate them rapidly. So in ZBrush the process is pretty simple. You go into the Z plugin Decimation Master, you set your decimation value, and you have to pre-process the subtool first so that it will calculate the different level of decimation and then apply it, and you will see your poly count reduce. Since this character is pretty simple, it doesn't have any equipment, or at least very few. My target is to be around 1 million polygons so that my computer will be able to handle it pretty smoothly in Blender. Further on, I think I was slightly upon this value and I re-decimated it in Blender just for the retopo and reloaded the higher poly version for the baking so that I have very smooth stuff. So now I will be importing my high poly mesh inside Blender using an OBJ format from ZBrush, because my Z plugin or add-on, if you will, GoZ, that allow you to communicate between ZBrush and Blender, doesn't work, and I feel lazy reinstalling Blender or reinstalling ZBrush and relinking everything. My workflow for retopology is pretty standard. I add a plane or a cube generally, then I center it, and I use a mirror modifier with the clipping on the x-axis. Then I will enable the snapping tool onto the surface for each point, and I will just start extruding my polygons along the surface of my character. Once I've surfaced the upper jaw, I will draw a first circle. So I changed my mind along the way and decided to add a circle so that I have more even topology, and then I will extrude it and scale it down so that it creates my first loop around the eye. Then it's just a matter of connecting those newly creating vertices to the upper face jaw or this surface by adding eventually a loop cut. Regarding polygon's density, I'm just trying to keep it as low as possible. And the thing is that I just shape the character. The thing is that your low poly character should look like your sculpted character, meaning that you should be able to read the main shapes of this character onto the low poly model. So if you can't, you might be a bit too low, but adding too much polygon will be a problem performance-wise. So once I've modeled the top of the head, I will go for the top fin. So the idea is to create a nice grid following the line of the back, because I want to be able to rotate this fin or to bend it on the side, so that whenever your character is moving his head from left to right, the fin will also move from left to right. So it's important to have a good poly flow and a good topology there. So this is why I will be tweaking this area of the character pretty oftenly. Regarding connection or caps, let's say, whenever you have to feel the tip of the fin or any area like this, the thing is that with low poly, as we won't be using any modifier like the subdivision modifier, you don't really care about the topology, meaning that you can use triangles, and triangles are very useful in low poly because you can even create joints with this kind of polygon using triangle, and I will show you some tips later on. As this area is a bit tricky, I will use isolation, like using the slash key just to see my low poly mesh, or use the Alt B to isolate the view because the side fin of the head are occluding my view. I'm also using the Retopology add-on, so you can see those green lines, for example, are the Retopology add-ons move tool. It allows you to slide the loops along the surface, so it's pretty handy. And also whenever you will add a cut with it, it will cut your mesh and snap it to the surface, so it's pretty handy. Retopology is a very useful add-on, but I use only a few features that are included because I'm so used to make Retopology by hand that it's faster for me to do it this way. But I must say that the loop cut, the contour tools are really handy. The next steps are pretty straightforward, so I will speed up the video, but first I would like to show you something regarding joints when you are doing a low poly character. Let's consider this simple tube as a limb or a finger, for example, with a simple loop as a joint. If you stay like this and try to rotate or bend this, you will get weird results. So I will use the 3D cursor as a pivot point, and I will start to rotate those. So let me select the upper vertices, and what you can see is that I got a weird deformation there. So this is where you should tell me, okay, so add some joints, so I will do it. I will add supporting edge loop so that the deformation will look better, and it will for sure. So the idea is to have a slight fall off when rotating those loops so that you don't have this weird deformation of the limb or the finger. And you'll have to deal with the weight paint when your character is rigged to do it properly. The thing is that you can create a triangulated shape using the knife tool, so I press K to enable it and press Z to cut through my model, and I will cut it with this triangulated shape, and you will understand rapidly why. Using this method will allow me to bend the limb or the finger and keep the corner of it very straight, very hard, and so that you won't have this sausage effect. I can even get rid of the center loop to get better deformation. I will now speed up the video for a while because there is nothing much to say, and I'll see you later in this video. During the retopology stage, I haven't connecting the pelvis or the hips to the body because the body can be mirrored, and I want to use mirrored UVs so that I have a better textile density. The thing is that the legs were retopologized separately because they can't be mirrored, because he has this shirt around his waist that he used as a shorty or something like this. So I will try to create my UVs from this point, and then I will reconnect everything once all the maps are baked. For the time being, I'm placing my seams, so I'm always trying to hide them. So I consider the arm as a tube, so you just need to separate it transversally by cutting under the arm along its length. And then I'm separating the end by cutting them following the edge loop that goes around the fingers. And as the tip of the fingers is pretty squarey, I just make a slight turn around the tip of the fingers with my seam. Using seams, I will separate the fin on the arm, and then I will cut them in half transversally so that it will be very easy to unwrap them. And also we should not see any seams because it's on a very sharp edge. I will proceed as well for the fin on the head, and I will also try to separate the head by following the crease under the neck. Generally, you will have, even if you place your seams weirdly, a seamless texture set on your character. But there is one map that may cause you problem, is the normal map. So if you are using a pure albedo or pure diffuse character for your game, you don't really need to be super careful on the way you unwrap it, because once painted you won't be seeing the seams. But if you're using a bit of normal map or bumping or stuff like this, you should try to hide those seams as well as possible. So it means that you may choose to hide them like here in the creases or in the sleeve of the pants or things like that. And then just try to focus on the simple shape here. My foot are just boxes, so if I separate one face of this box, the other one should be able to unwrap properly if I cut one line inside the leg. So you can see this straight seam that goes from the inside of the thigh to the foot. Then I will proceed the same way with the accessories, so it's pretty straightforward for the accessories. You may separate your seams or cut them per material in a way. So like here I have the straps, I have the blade, and I have the handle, so I can place my seams pretty easily here. And then for those spikes, I will just isolate them by cutting a loop around their root, and try to cut also the tip of those spikes to avoid distortions. Once I'm done, I will go into unwrapping. So generally I use the Atlas add-on, but here I faced some issues, so I decided just to get rid of all the mirror modifier, join every single part into a single mesh, and then just press A, U, and unwrap everything so that it goes way faster. So I've created a material in cycles and just added a texture node, and I've loaded a texture I have created. I called it Baker, and used the checker, so it allows me when I switch to texture mode to see if I have any distortion onto my texture. So here you can see that the checker distribution is pretty even, so I consider that my texture is okay and my UVs are okay. So then my method to organize the UV map is to first place the biggest chunk of the UV, the biggest island, and then I will go down the road placing the smallest part, trying to fit a virtual square, let's say, so that then once I'm in, I will be able to scale everything up to fit the whole UV space. So I will rapidly finish to place all those UV islands, making sure that I haven't any crossing geometry, and once it's done I will put my pivot point to the top left corner, select everything, and then scale everything so that I fit as much space as possible without getting out of the UV boundaries. For the baking stage, I first plan to use a cage to bake my texture so that I get the best result. So currently a cage is a mesh that fits the same topology as your low poly mesh, so currently it's just a duplication of it. And then you will make sure that this cage, this newly created mesh, bounds the sculpt, the high poly mesh. So what I will do is that I will duplicate the torso and then I will start pushing along their normals the different faces of it until I get my high poly mesh totally covered by this newly created mesh. This cage will be used to cast the rays inward so that you can calculate the distance and the curvature of the high poly mesh onto the low poly mesh. So this is, let's say, the best way to get nice result, but it's pretty tedious, and sometimes the time you will spend here won't worth the money, let's say, because you will sure get better results, but we can get very nice result using the classical way, and I will switch to it later on because I get lazy and I didn't get that much value, but it's an important method. For organic shape it might not be mandatory, let's say, but if you are working really like a professional, you should use this method as often as possible. But if you're working on hard surface modeling and you want to bake nice normals for games, I think it's mandatory to use this method because you will get way better normals and stuff like this, and there will be way more precise. So the idea is that using the cage will allow you to have optimized distance between your high poly mesh, your low poly mesh, and the distance the ray are casted to bake the normal map. So I will show it to you what I'm talking about a little later on in this video. So let's say this yellow line is my low poly surface, and then I have this as my high poly surface. When you bake a normal map or whatever it is, Blender will cast rays inward in the opposite direction as your normals from your low poly surface. So if it doesn't cross anything from the high poly surface, you won't get any informations. When we are using a cage in red here, Blender will cast the ray from this cage so that it will cross the high poly model in green and write the information onto the low poly surface. Using a cage will allow you to optimize this distance, making your ray casting object as close as possible to the high poly model, avoiding any distortion in the ray casting, and so translating it into a clean normal map. But we can also do it by hand using the ray distance, and then Blender will cast the rays with an homogeneous distance from the low poly mesh, so it will kind of offset the size of your low poly mesh. The problem is, in certain area like between the fingers and stuff like this, if you offset too much this distance, you will have crossing geometry, and this will generate artifacts onto your baking. So the idea here is to find a way to solve this. So I will move my cage onto another layer, select first my sculpt and then the low poly mesh. I have a material onto my low poly mesh with an empty image texture I am saving here. And then I will go into the baking options, select normal, put a margin of 4 and add a cage, and then I will just click bake. Normal maps are generally pretty fast to be calculated, so you need to smooth your shading first to avoid this polygon pattern onto your normal map. So I will click bake again. It will take a few seconds, and then I will have a clean normal map for the upper part of the body. Then I will rapidly test it using a glossy shader with cycle and plugging in this normal map. So you can see the difference between the low poly and the normal map applied. Then I figured that I have some issues with the center line, so I've tested different methods to fix this, and I ended up painting a bit the normal map to fix this. And as I got lazy, I just used this simple method to calculate the ray distance by enabling the normals onto my character, the normal display, and then just moving slightly their value until I can see all of them crossing the high poly model. I can then report this value into the ray distance and get rid of the cage. I will then repeat the process for each part of the character, making sure that I remove the clear option so that the newly baked normal map will be written into the empty space of the current normal map, and I will have a single normal map baked from different objects. So for the main body, I've baked the normal map with two different scale distance so that I get some better result in certain area like between the finger, but since I lose some detail on other area, I then combine them into Photoshop and just mask the bugging area so that it allows me to fix it. Honestly, I got a pretty decent result, and the bugging area were pretty occluded, so it wasn't really a problem. And then I've made some fixes by painting onto the normal map inside Blender to fix them. You can do this directly in Photoshop using the corrective brush, but for me it doesn't work as well than doing it by hand, because when doing it by hand you can smear and push the colors and the normal map following the flow of your sculpt, and so it will look very nice. So those greenish points here are typically crossing geometry. So with different length I can generate two normal map and mask the bugging one. So this is not the much fun part of the process, but This is very important because those little buggy area will be outputting on your character, and you don't want that when you have spent so much time to sculpt, retopologize, UVs, baked, etc. Spending like 10 minutes just to fix your normal map is not a big deal, and the output will be nice and clean. I mean, if you're working for yourself or for a customer, the thing is that you don't want to be disappointed, and you don't want your customer to be disappointed. Whenever there is some issue on a character, even if it's the best character ever, if your customer or anyone else just spot it, their attention will be focused on the problem, not on the quality of your character. So it's always important to do as best as you can. I have baked the ambient occlusion using exactly the same method as before, but I just made sure that I had only one mesh on the active layer, avoiding, for example, the necklace to project an ambient occlusion onto the body. Then I fixed the issue as I did for the normal map. There is always small issues, but that's pretty fast to fix them. Then I've also baked an object normal map in the object coordinates, so that it gives you your basic geometry information, but also the location of this geometry. And this is very useful to generate some base color map later on. So here you can see how it looks, and as usual I will be fixing it by hand. Then I've welded back all my meshes together, and I fixed the hips and joined the legs to the whole body, so I didn't got that much distortion. And then to generate the curvature map or pointiness map, I didn't use Blender because I really don't like the pointiness node. I think it's too sharp, and I don't know, I don't like it. It doesn't output a nice curvature map. Thankfully, I found salvation using Daniil Bekucha Blender file that allow you to convert your normal map into different curvature map or pointiness map, and they are very, very clean and nice. So a big shout out to him. You should follow him on Twitter because he's working on a lot of different solutions in Blender to get this hand painted style and output nice curvature map and all other hand painted style map procedurally. So here you can see he has combined different node setup into a single Blender file that you can find on his Twitter page, and it allows you from your normal map to output very, very nice curvature map, as you can see here. So there are different level of contrast, of depth, etc. I've just tried 3 different curvature map, generated them, and then I will be using them or trying them inside Blender during my painting process. So again, super easy, super handy, and you will get the best curvature map that you can output from Blender for sure. I will then switch to Blender 2.8, load my different map, And using the normal map in object space, I will use a separate RGB to get the blue channel that will allow me to get a gradient texture that allow me to see the top to bottom values of my character. And using a color ramp or a mix RGB, then I can generate a base color onto my mesh. So here you can see how it looks without any normal map or whatever. And I have some color information and some geometry information baked into a simple color map that will allow me to have a base to paint. I've also painted an ID map by just filling a different color for the different parts of the character. I will be combining my grayscale map from the normal map in object space with color and bake this and start painting on. The whole painting process will be covered in the next chapter. So as usual, if you enjoy my content, don't forget to give me a like and subscribe. I know everybody is saying this, but this is very important for us to exist through the YouTube algorithm and into the community. So thanks, and I'll see you on the next part very soon.